Recording started.
Well, welcome guys. If you could please place the check mark over your name, your student, that would be great. And hopefully you've done the homework or the warm-up I sent out, and that was to load your video that I sent to you to your physics folder and the hard drive. Do not leave it in your downloads. It actually needs to be in your hard drive. So if you could move your check mark over to your name, Nathan. Okay, so let's go ahead and start doing a warm-up so that we could get our physics brains working. Okay, so we're waking up our physics brain with some practice on positive direction or negative direction. So which direction is the rocket going? Positive horizontal, positive vertical, negative horizontal, or negative vertical? If you could go ahead and warm up our physics brain for a few minutes on directions. Press A, B, C, or D. Excellent. This is going in the negative vertical direction. Good job, guys. Okay, which direction? He's throwing the basketball in the upward direction. Positive horizontal, positive vertical, negative horizontal, or negative vertical. A, B, C, or D. Excellent. Positive vertical is correct. Two more. Which direction is Odie from my generation running? Is he running in the positive horizontal, positive vertical, negative horizontal, or negative vertical? Yes, correct. He is running in the positive horizontal direction because it's to the right. And the last one, Bugs Bunny. Which way is he going? Positive horizontal, positive vertical, positive vertical, negative horizontal, or negative vertical? Nathan, thank you. Nick, thank you. Both excellent. You guys are really warmed up, ready to go. He is running in the negative horizontal direction. So what we're going to do tonight is we are going to go over a problem. We are going to learn to use some new instructional technology. Okay, so our problem is, what can we learn about the motion of an object by doing video analysis? So our learning target, by the end of this session, I can do video analysis on a moving target. So the warm-up, hopefully you loaded the video that I sent you to your physics folder in your hard drive. Hopefully you did not leave it in your downloads. We'll go for a smiley face. Give me a smiley face if you already took care of moving your video to your hard drive. Thank you, Nick. Appreciate that. Thank you, Nathan. Excellent. Okay, so this is SOL Standard Physics 2. Students will investigate and understand how to analyze and interpret data. Some key concepts include A, the description of physical problem is translated into a mathematical statement in order to find a solution, and we will be using instructional technology for that. So here is our problem. Mr. and Mrs. Smith return home one evening to find their second-story bedroom window is broken. The break is 3.1 meters above the ground. It's a beautiful fall day and the kids were off from school for a teacher workday. Angrily, Mr. Smith watches the video surveillance. He sees the neighbor's kids playing ball right under the window. Did the kids break the window? How could you go about solving this problem before calling the parents? So when we do problems, we're hopefully going to follow this three-step procedure that we've been following. We're going to your page that you're going to see is going to look like this. So here's your problem. You're going to see this when you go into your breakout rooms. You're going to go ahead and work together with your partner. You're going to collaborate. And you're going to communicate together on what you do know, what you can figure out, it's assumed knowledge, and what it is that you're going to list down as knowns and assumed pieces of knowledge. So just a second, let me get you into the breakout room so we can start solving this problem together. So,
that sounds good to me. I'm not much of an artist.
so how
I'm right there with you.
So how you guys doing? So what type of picture could you draw about this to get some facts down on the paper and some variables, the variables and the actual data that was given to you? Oh, look at that, I see a house. I'll let you guys work at it.
Sounds good, thank you.
Yeah, that's really nice. I see a little bit of a parabola going up as the ball's going up, reaching the high point. What do we know about that? Oh, we know acceleration. What do we know about that high point? The very, very tippy top when the ball is going upward and then starts going downward. What happens to that velocity that we can take advantage of for some of our formulas?
Velocity is 0 meters per second at the trough of the parabole.
Yeah. Yes, right when it's at the very, very top at the crest, yes, it would be at 0 meters per second. So that's something we could take advantage of since it can't go up and down at the same time. That's perfect. So it looks like we've got it all. I'm going to return you guys back to the main room. We'll take that slide with us and we'll see what we come up with. So thank you for what you did. The picture looked great, and the information that you put down about the values. So let's make a list of what we know. Just go ahead and write it, and this would be a whole class activity. It's very good. So we know that the velocity at the maximum height is going to be 0, and we can take advantage of that. Be nice to know a time. It'd be nice to know a delta y, and it would be nice to know an initial velocity, and we could probably do that. So we can find some of this, and we can find something like this. And I'm going to take you to I'm going to share my screen with you. And as I share my screen with you, that will give me a screen that looks like this. We want this screen, so go ahead and split your screen and go find LoggerPro in the bottom left-hand corner where it says Type to Search. You want to go ahead and find LoggerPro. When you have LoggerPro and you've split your screen, I'd like for you to give me a smiley face so I know you're with me, I know you're ready to go on. Thank you, Nick. Thank you, Nathan. So now what we're going to do is we are going to insert the video. So to do this, we go up to the screen where it says Insert. We go down to Movie. And we go to the file where we put the movies. So, oh, I'm sorry, and I should tell you that it automatically comes up with experiments. You're going to have to go to your libraries and go to your documents and choose where you put it. And here I've got my student, and we did this lab in my physical classroom, so that it went pretty well. And we're going to minimize this screen just a little bit so we can see the X and the Y column. So hopefully you see this on your own screen. If you see Jalen, that's my student, give me a smiley face so that I know that you are good. Thank you, Nick. Nathan? Smiley, you with me? Thank you, Nathan. Okay, so at this point when he's getting really close, I'm going to press the button at the bottom of my screen that has those 3 dots, bottom right-hand corner of the picture. I'm just going to press it, and now I'm going to be allowed to advance my screen frame by frame. So right as he's about to release it, I can then press the second button on the right-hand side, and it's going to say Add Dot. I'm going to add a dot right there. And it automatically advances the next screen for me. And oh look, the ball's released. So this looks familiar. This looks like just like the motion maps we learned to make earlier this year. So as you see on the left-hand side of my screen, I have some x velocity numbers and some y velocity numbers, and they're pretty high. So what I have to do is I have to set the scale. That's going to be the 1, 2, 3, 4th button down. I'm going to set the scale just by using that meter stick. Just going to calibrate it to that meter stick, and it gives me the option of distance 1 meter. I'm going to click OK. And then I'm going to be ready to look at my numbers. And if I see over here, my numbers are pretty good. So there's one little problem with them, and I'd like you to use the chat feature about what's the problem with my numbers. Look at what the screen's doing. It's going which direction, and the screen is only going to be able to do, or the program is only going to be able to do what you tell it to do. So does anyone have any ideas that you can chat in the chat room about what might be happening? Why are we getting these negative numbers? We just did a warm-up as to why, of what direction. We know it's going up. Why are the numbers negative? If you could chat in a response. Yes, thank you, Nick. The video is sideways, and flipping this video is not something we've been able to do, but it's still useful because I know that my direction is going upward. So I'm getting what I need from this video. So if I look over here where I'm circling, I know that my person started throwing that ball at 14.017 meters per second, and that's in the up direction. So right now we do have an initial velocity, and that initial velocity is all we need to solve the rest of the problem. So this is something that you're going to be doing in your lab. As you do your lab this week, you're going to be taking a cell phone video, and you're going to be finding, can you break this window? Can you look at your initial velocity derive the formula from our set of formulas, our four famous formulas. Can you